Hi learners, welcome to this session where we are going to discuss the LANJET Pre-Mock Cluster Joint Evaluation 2024 Physics Paper 1. Invite your friend, share the link, and at the end of the session, drop a comment on how you feel the lesson was. Let's see question number 1. The figure below shows a vernier caliper scale. If the scale used had a zero error of negative 0.02, what is the actual reading of the scale? So dear learners, for us to get the actual reading of the scale, first of all, let's get the vernier scale reading. So first I'm going to get the main scale reading. The main scale reading. How do I get the main scale reading? I'm going to read the reading before the zero mark of the vernier scale. So that is 8, 8.1, 8.2 before the zero mark of this lower scale. So that is going to be 8.2. Maybe I can say 8.20. Then I'm also going to get the vernier scale reading. The vernier scale reading. The reading on the lower scale where I'm going to have some divisions coinciding with each other. So I'm having 0, this 1, 2, 3. If you look at the division on the third mark on the vernier scale, it coincides with the division on the main scale. So that's where I'm going to stop from. So that is 0, 1, 2, 3. So I'm going to take to multiply it by 0.01, making it to be 0.03. Then I'm going to get the total reading. Total reading for it, you are going to add to get the total reading. So this will be 3, this will be 2, this will be point, this will be 8. So that is 8.23 8.23 centimeters. Now we are told we have this as our error. It's a negative zero error. How do we correct a negative zero error? We fix a negative zero error by adding. So to get the actual reading, dear learners, to get the actual reading, we are going to take what we've read from the vernier scale, so from the vernier calipers, that is a 8.23. Then we add the negative zero error because we correct the negative zero error by addition. You add the 0.02, that is going to give you 8.25 centimeters. 8.25 centimeters, and that is the solution for question number 1. Question number 2. Find the total pressure exerted by a diver 8 meters below the sea surface. Take atmospheric pressure to be 103,360 newtons per square meter, and the density of the sea to be 1030 kilogram per cubic meter. So to get the pressure experienced by the driver, to get the total pressure, to get learners to get the total pressure, what are we going to do? We are going to take atmospheric pressure plus the pressure due to the sea water. We are going to take atmospheric pressure plus the pressure due to the sea water, which is going to be given by H rho G, plus the pressure due to the sea water, which is being given by H rho G. What is our atmospheric pressure? Our atmospheric pressure is 103,360. So this is going to be 103,360. You add, we're going to add, what is the height? The height is 8 meters, because they've said this person is 8 meters below the sea surface, so it's 8 times the density, which is 1030, then times the gravity, which is 10. When you do that combined in your calculator, dear learners, you are going to get 185,760. 185,760 pascals or newtons per square meter. Remember, you leave it in SI unit. So learners, that's how you work it out. Total pressure is given by atmospheric pressure plus the pressure due to the seawater, which is given by H rho G. Question number 3, learners. The figure below shows an electric heater placed midway between flasks A and B. Flask A is shiny on the outer side and B is blackened on the outer side. Name the process by which heat travels from the heater to the flask. Name the process. Learners, when you look at the heater and the flask, there is no medium in between them, meaning it's a vacuum. Therefore, learners, the process by which heat is transferred via a vacuum is radiation. So the process here is by radiation. So our process here, learners, is radiation. That is the process by which heat travels from the heater to the flask, because in between the heater and the flask here, there is no media, learners. There is no media here, so it's a vacuum, and heat by radiation is via a vacuum. State the observation made. State the observation that will be made. So learners, for us to make an observation, remember this heater is emitting heat, and heat will reach both flask A and flask B. Flask A is shiny on the outer surface while B is blackened on the outer surface. So what observation will be made? And we have the water levels on limb X and limb Y. So what we expect is that because it's just stating the observation, the level of the liquid in Y will decrease and the level of the liquid in X will increase. Why will this one decrease, learners? I want to have a better understanding on how that is happening. Remember that this one, flask B being blackened will absorb more heat. Once it will absorb more heat, it will become hot and increase the temperature here compared to here. Once it increases the temperature, it will make this water hot, therefore flowing towards the X limb, X. So the observation here, you simply say the level of the liquid in Y decreases, because it's just stating. Remember, with the science, you just need to be precise. So it's just saying the level of the liquid in Y decreases. The level of the liquid, in Y, the level of the liquid in Y decreases. The level of the liquid in Y decreases, and the level of the liquid in X rises, and the level of the liquid and the level of liquid in X increases, learners. I've given you the explanation for that. But now, because the question just is saying to state the observation, you just state to get that 1 mark. The following is a graph of force against extension for a spring. On the same axis, sketch a graph of force against extension for a spring double the length, same thickness, same material as this above. It's only that the length has been doubled. It's only that the length has been doubled. So learners, what do we learn in that case? What do we learn in that case? Remember that F is equals to KE. F is equals to KE. And K is equals to F over E from Hooke's law. K is equals to F over E. Now learners, what we need to know is factors affecting spring constant. How does length as a factor affect the spring constant? Learners, you must have talked about that. And when you're very keen, you'll realize for us to give the sketch of this line, then it will be a straight line passing through the origin, but below there is a normal line. So it will be a straight line. It will be a straight line passing through the origin, but slightly below this one here. So it will be such a straight line, learners. The concept is that line should be below the line that you've been shown there. Water flows steadily along a horizontal pipe at a volume rate of 8 times 10 power negative 3 cubic meter per second. If the area of the cross section of the pipe is 20 squared centimeters, calculate the velocity. Calculate the velocity. How do you get flow rate? Flow rate is equals to AV. Hope we know that. Flow rate. When we talk about the flow rate, that is the volume rate. Let me maybe just talk about the volume rate directly. Volume rate, to calculate volume rate, is equals to cross-sectional area times V. So my volume rate here is 8.0 times 10 power negative 3 should be equals to A, which is 20. To its SI unit, I'll be multiplying it by 10 power negative 4 V. This simply means to get my V, I'm going to take 8.0 times 10 power negative 3 divided by 20 times 10 power negative 4 divided by 20 times 10 power negative 4 times 10 power negative 4, and that gives me 4 meters per second. We just play with some basic maths here. That volume rate, the volume of water passing through at a certain point, is the cross-sectional area at that point times the velocity in which the water is flowing. So by substituting and making V the subject, we are going to get V is equals to 4 meters per second. Question number 6. The parallel forces are acting on a body of a mass 0.7 newtons, as shown in the figure below. Calculate the acceleration of the 0.7. Learners, if you look at this mass, we have a force pulling it to the left, that is 12 newtons, and we have another force pulling it to the right, that is 25 newtons. So let's first get the accelerating force, the force that is making this body to move. Because we have 12 newtons on this side, 25 newtons on this side, then what is the accelerating force? Accelerating force is that accelerating force is the force that is now moving this mass, is given by 25 25 minus 12. 25 minus 12, which is 25 minus 12 learners, you're going to get 13 newtons. 13 newtons. And from Newton's second law of motion, you know that F is equals to what? Ma. From Newton's second law, we know that F is equals to ma. That means, what is my F? My accelerating force, which is now 13, should be equal to the mass of the object, the mass of the body, which is now 0.7, times my A, which we are looking for. So my A is simply 13 divided by 0.7, dear learners. What do you get in that calculation? 13 divided by 0.7, I'm getting it as 4.286. 4.286. It's acceleration, so the unit should be meter per square second. It's acceleration, so the unit should be meter per square second. So learners, that is basically how you would have answered that question. First, make sure you get the resultant force, because from these 25 newtons, 12 newtons from it is used to overcome the opposing 12 newtons. Those ones cancel out, so the remaining 13 newtons now will be the force that will be responsible for moving yeah, sorry, this one is not 13, so this one is not 4, that should be 18. Sorry for that calculation. When I take 13 divided by 0.7, I should be getting 18.57 meters per square seconds. By calculation, that is what you should be getting, dear learners. That's what you should be getting. Question number next is the pressure law. This is from gas laws. We are required to state the pressure law. Learners, how do we state the pressure law? It's not that difficult to state the pressure law. Remember, laws in physics are stated exactly the way they are. So the pressure of a fixed mass of a gas is directly proportional to its absolute temperature, provided that volume is kept constant. The pressure of a fixed mass of a gas. So let's write the pressure of a fixed mass of a gas. The pressure of a fixed mass of a gas. The pressure of a fixed mass the pressure of a fixed mass of a gas is directly proportional to its absolute temperature. Is directly proportional to its absolute temperature at a constant volume, provided the volume is constant. Provided volume is kept constant. Volume is kept constant, learners. Constant. That the pressure of a fixed mass of a gas is directly proportional to its absolute temperature, provided that volume is kept constant. Remember that For a very smart learner, if you just know this combined equation, P1 V1 over T1 being equals to a constant, it will really make your work quite easier, learners. Knowing that combined equation will make your work quite simpler. Now, because let's look at how this formula is going to help us in doing part B. Air is compressed at a constant temperature until its pressure rises from 82 centimeters of mercury to 140 centimeters of mercury. If the initial volume of air is 85 cubic centimeters, find the final volume. Now, learners, you learn, because they are talking about pressure in volume, I'll come here and see how does P relate with V. I know that P1 equals, from here you know that P1 equals to V1, P1 V1 equals to K. So I'll come here and talk of it like this now, because I've known that. I'll now say P1 V1 should be equals to P2 V2. What is our P1, dear? What is our P1? Our P1 is 82. This pressure, 82 times volume 1. Times volume 1. What's our volume 1? It rises from this to this. If the initial volume is 85, meaning 85 is volume 1. So times 85 should give me P2, rises from this to this. So this 140 is our pressure 2. So should be equals to 140 times V2, which we are looking for, the final volume. If I make V2 the subject of the formula, I'm going to get V2 can be written as 82 times 85, divide this by 140. 82 times 85 divided by 140. You use your calculator. 82 times 85, close the bracket, divided by 140, 49.79. 49.79. I'm getting 49.79. I've written mine to 4 significant figures. 49.79. And that becomes your answer. You just need learners to know this combined equation. Once you know this one, your work becomes quite easier. Once you know that one, your work becomes quite easier, because you just look at the variables you are given, then you see, could they have related volume and temperature? You could have said V1 over T1 is equals to V2 over T2, and vice versa. Question number 8. Question number 8. Explain the cause of the random motion of the particles as observed in the Brownian motion in a smoke cell experiment. Learners, the cause of the random motion, it is simply due to collision with the invisible air particles which are in constant random motion. That's what we need to know. Explain the cause of random motion of particles. So you can say this is due to collision with the invisible air particles which are in constant random motion, random motion. This is due to collision with invisible air particles that are in constant random motion. So that's what is causing the random motion. Question number 9. The figure below shows a machine used to raise a load. Use the information given to answer the questions below. Determine the velocity ratio. How do you determine the velocity ratio? In this case, learners, for you to determine the velocity ratio, you count the number of ropes. Number of ropes moving against gravity. Moving against gravity. This is the simplest way of getting the velocity ratio. For example, if I look at this load, this wheel here, it's being supported by this one. This one is going up, so that's 1, 2, supporting this load here. So also this wheel is being supported by this, that's another 3, 4. This one here, this one you will get it as 5, 6. It tends to lift it upwards against the gravity. So in that case, this one is moving downwards, so we cannot count it. So you realize that the velocity ratio here is 6. The velocity ratio here is 6. VR is equals to 6. And I've told you the secret is you just count the number of ropes supporting the load by lifting it up against the gravity. I'm not counting this side here because this side is moving downwards, so I cannot count that side of the effort. So learners, that's how easy that question was. If the load of 800 newtons is raised by applying an effort of 272 newtons, determine the efficiency. So because we've been given the load and the applied effort, that helps us to get what is called mechanical advantage. Because the ratio of load to effort is mechanical advantage. First of all, let's get our mechanical advantage, which is normally given by load over effort. Our load is 800 over our effort, which is 272. So 800, you're now having 800 from your calculators. 800 divided by 272, you are getting 2.941. 2.941. Remember, it's a ratio, therefore it has got no units. After now we've gotten our mechanical advantage, you know that how do you get efficiency? Having mechanical advantage and velocity ratio, you know that mechanical efficiency is equals to mechanical advantage over velocity ratio times 100%. My mechanical advantage is 2.941 over the velocity ratio, which you got at the top here, 6, expressed as a percentage, learners, by multiplying it with 100%. So what do you get in that case? So you are going to get, when you do that multiplication, you divide that then by 6, 49.02%. 49.02%, and that is the efficiency of that system, 49.02%, and you'll have gotten it correct, learners. Let's look at question number 10. The figure below shows a liquid in a long cylindrical tube closed at one end with a cork. The cork is tight fitting but movable. So you see, we have a cork, we have a liquid. State and explain the observation that will be made when the tube is heated uniformly. when we heat the tube containing the liquid uniformly. State and explain. There you need to state, then explain what you've stated. So what you need to know that upon heating, the tube will tilt in the anti-clockwise direction. Why? Because the liquid moves left, pushing that cork. You know that we have the cork there. Once we heat, this liquid will tend to expand, and as it tries to expand, the only thing that can be pushed is, as it's expanding, it's trying to occupy more area, so it has to push this cork towards the left hand side. So once it pushes the cork, a lot of liquid will come towards the left hand side, making the left hand side to become heavier compared to the remaining one on the right hand side. Therefore, that will make this tube to tilt in the anti-clockwise direction. So the explanation to this, allow it right here. I'll say the tube tilts in anti-clockwise direction. I'm first stating the tube tilts in anti-clockwise direction. That is the observation I've stated. Then after I've stated, I have now to give the explanation to what I've stated. I'll say the liquid expands expands on heating. The liquid expands, comma, pushing the cork towards the left. Pushing the cork towards the left. Pushing the cork towards the left. Pushing the cork towards the left, I can say. Pushing the cork towards the left, resulting to anti-clockwise moments, resulting to anti-clockwise moments becoming greater than clockwise moments. Becoming greater than clockwise moments. Becoming greater than clockwise moments. So that's all the explanation. I've now gotten the 2 marks. By just saying the tube tilts in the clockwise direction I've stated, I get a mark. Then correct explanation to my statement that I've stated, I get another mark. Let's get to section B. State Archimedes' principle. Learners, remember, principles in physics are stated the way they are in the KLB, not any other textbook. So we say, when a body is partially or totally immersed in a fluid, I'm stating it, when a body is totally or partially immersed in a fluid. When a body is totally or partially immersed in a fluid, comma, it experiences an upthrust it experiences an upthrust. It experiences an upthrust. It experiences an upthrust equal to the weight of the fluid displaced. Equal to the weight of the fluid displaced, equal to the weight. So learners, that is how you state Archimedes' principle. When a body is totally or partially immersed in a fluid, it experiences an upthrust equal to the weight of the fluid displaced. Equal to the weight of the fluid displaced. As simple as that, dear learners. Nothing else that you are to do there. Let's look at part B. The figure below shows an experiment used to determine the density of an irregular piece of metal. The mass of metal in air is 200 grams. So we have two figures there. In the first figure, it's not immersed in water. So when it's in air, its mass is 200 grams. Then in the next figure, and remember that we have the volume there. In the next figure, we're seeing it is fully immersed in water and the volume has risen. So the question is, determine the volume of the stone. So what we know from Archimedes' principle, the volume of a stone should be equal to the volume of water displaced, because that stone occupies, when you talk about volume, this is the amount of space occupied by an object. So if the volume of a stone is 20 cubic centimeters, when we immerse it, it is going to displace water that has the equal volume of 20 cubic centimeters. So let's first, we'll get this by saying volume of stone should be equals to volume risen. I can talk of it, volume that has been displaced. I'm a volume that has risen. So how do you get that? What was the initial volume? This also tells us that we need exactly to know what does each small division represent. So this is 51.1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you see, learners, we need to be so keen when you look at the reading here. What is the reading of the water? I think this is a typo. This should have been 50. This is 50. This should be 61. 1, 2, 3, 1, 2. This should have been 61. If not 61, not 61, but I'm seeing it as I'm just seeing this as a typo. This should have been for uniformity of the units. This should be 52 and not 51, so that after 10 divisions you get to 62, the way this one is here. Learners, if you look at it keenly, it means what is the final reading. To get the volume that has risen, you take the final reading. After the stone is immersed, the volume has risen to 62.1, 2, 3, 4, 62.4. So that is 62.4. I subtract the volume before we immerse the water. That is 52. This one should not have changed. 51.2. 51.2. Sorry. So learners, you see, before the stone was immersed, the reading here was at 51.2. This reading was at 51.2. After the stone is immersed, the reading is now at 62.4. So to get the volume that has risen, you do the subtraction, and that becomes, when you do that subtraction, learners, what do you get? Let me write it from the top. When you do that subtraction, learners, you are going to get just a moment, thank you. You are going to get 11.2. That is this one is a measuring cylinder, therefore it is in centimeters, so this one is cubic centimeters. And someone says, but the question was in cubic meters, so this one you divide it by 1,000,000, or you simply take it the way it is, 11.2 times 10 power -6 cubic meters. It's also correct, cubic meters, like that, cubic meters. This is power 6, don't forget that, cubic meters, and you are done with that. So that's the volume. Next, we need to get the density. How do you get density, learners? You know that from form 1, density is mass per unit volume, so density is equals to mass over volume. What is the mass? Let's work it out. The mass is 200 grams, so that is 200 over the volume in centimeters was 11.2. So this gives you, when you divide 200 divided by 11.2, I'm getting 17.9 grams per cubic centimeters. Or someone else could have done the calculations in kilogram per cubic meter. Still, you could not be penalized because that's an open question. That's how you do it, learners. Given that, part C, given that the density of water is 1 gram per cubic centimeters, determine the volume, the mass of the water displaced. So first of all, because you know that the volume of the stone was equal to the volume of the water displaced. So you know the volume of water displaced was also volume of water displaced is 11.2 cubic centimeters. And you know that density is, how do you get mass? Mass is equals to, from density is equals to mass over volume. Then it means mass is equals to density times volume. So that means my mass is equals to the density, which is 1, times the volume, which is 11.2. So my mass in grams is going to be 11. My mass, wait just a moment, volume of water, just a moment. Let's get back to Archimedes' principle, learners. What does Archimedes' principle say? A floating object, when an object is totally or partially immersed in a fluid, it experiences an upthrust that is equal to the weight of the fluid displaced. It experiences an upthrust equal to the weight of the fluid displaced. Now here we've been told, calculate the density of, the mass of the water displaced. Mass of the water displaced is density times volume. The density is 1. Is the density 1? Let's rethink on that question, and let's see what exactly was required of us. The density is this one. So learners, let's agree here that there's something we are leaving out, and it's not good to leave it out. Just a moment, let me check, let me redo something here. You know that density is given by mass over volume. But also remember, learners, that we need to get the upthrust the mass of the water displaced. And we've all come to an agreement that density is given by mass over volume. Therefore, mass is given by density times volume. Mass is given by density times volume. The density of the water is 1. My question is, what is the volume? What is the volume of the water displaced? Then, remember now in Roman 2, we will be talking about getting the upthrust. And that upthrust now should be equals now to the weight of the water that is getting displaced. That is should be equals now. So with this one, it is just like that. 1. The density of the water is 1. The volume of the water that got displaced was 11.2 times, not even times whatever, because this is in grams, so also the volume should be in cubic centimeters. So this gives me 11.2 grams. 11.2 grams. Then number next, the upthrust acting on the water. Remember that when an object is fully or partially immersed in a fluid, it experiences an upthrust. That is equal to the weight of the fluid displaced. That is from Archimedes' principle. So the weight of the fluid displaced, weight is equals to mg. Weight is equals to mg. Remember that. So it is 11.2 divided by 1000 times 10 power negative 3, bringing it to kilograms, then times 10 because of gravity. Having said that, let's do our calculation. Let's do now our calculation, learners. Let's do our calculation. Let's see what that is going to give us. Using our calculators, we can work it out. Using our calculators, we can work it out. With the help of our calculators, we can work it out. So that is going to be 11.2 times 10 power negative 3 times 10 power negative 3, then times 10. This is going to be 0.112. This upthrust is so that it's in newtons. 0.112 newtons. 0.112 newtons. And after that, we need to calculate the relative density. How do you get the relative density? Relative density. To get the relative density, it's simple again, learners. To compute the relative density, that is a relative density of the metal. To get the relative density, you simply take the relative density of a substance over the density of water. Density of a substance over density of water. Density it's not that clean handwriting. I want to change. Density of substance just a moment, I'm just fixing the issues with my pen. Density of substance over density of water. That is, the density of our metal was 17.9, sorry, 17.9 over the density of water, which is 1. So the relative density is 17.9. Learners, remember, because it's a ratio, then there are no units. It's a ratio, so we don't have units. A solid displaces 5.5 cubic centimeters of paraffin when floating and 20.5 cubic centimeters when fully immersed. Given that the density of paraffin is 800 kg per cubic meter, determine the density of that solid. A solid displaces 5.5 cubic centimeters of paraffin when floating and 20.5 cubic centimeters when fully immersed. Given that the density of paraffin is 800 grams per cubic meter, determine the density of the solid. So first, what we know is that a floating object displaces, when an object is fully immersed, it experiences an upthrust equal to the weight of the fluid displaced. So first of all, let's calculate the weight of the solid. You know that let's squeeze in this space. Weight of solid is equal to volume when floating times the density of paraffin. Volume when floating times the density of paraffin. What is the volume when floating? The volume when floating is 5.5 times 10 power negative 6 times the density, which is 800. This gives me just a moment. This gives me what? This gives me, when you do that multiplication, 0.0044 0.0044. But now learners, remember that this one is now in cubic meters and this one 800 is in cubic, so this one is in kilogram. This should be mass, not weight, because you know that density is equal to mass over volume. So this should be mass of the solid, not weight. I'm sorry for that, learners. This should be mass. The mass of the solid is given by volume times the density. Now, after getting that, just a moment, let me incorporate the units. So with this one here, the unit now should be cubic meter. Let me use a different pen to make it clear. Cubic meter is 5.5. That one is not writing. Oh, sorry. Then this one is kilogram per cubic meter. So this one and this one cancel. So that one is in kgs. That's correct. Then let's compute because they want the density. How do you get density? Density is equals to density is given by mass over volume. Mass over volume. Density is given by mass over volume. So the mass learners in that case is 0.0044 over the volume, which is 20.5. 20.5 times 10 power negative 6. What do you get? We use again our calculators. We use again our calculators in that case. We use again our calculators in that case, whereby we are going to get 0.0044 divided by 20.5 times 10 power negative 6. I'm getting times 10 power negative 6. I'm getting 214. I'm getting it as 214.634 is density, kilograms per cubic meter. Kilograms per cubic meter. Kilograms per cubic meter. Let's look at question number 12. Let's look at question number 12, learners. State one factor that affects the boiling point of a liquid. One is temperature. Temperature is one of the factors. So we have temperature. Another factor that affects the boiling point of a liquid is pressure. That's why when we are cooking ugali at our homes, we normally cover that sufuria with a lid. Why? To increase the temperature inside and also the pressure, so that because those are the factors that affects the boiling point. Question number B. 100 grams of a liquid at a temperature of 10 degrees Celsius is poured into a well-lugged calorimeter. An electric heater rated 50 watts is used to heat the liquid. The graph in the figure below shows the variation of temperature of the liquid with the time. We have on the y-axis we have temperature in degrees Celsius. On the x-axis we have time. On the x-axis we have time. From the graph, determine the boiling point of the liquid. From the graph, determine the boiling point of the liquid. The boiling point of the liquid is the point where the temperature is no longer increasing, the point where the temperature is constant. When you look at it keenly, learners, the point where the temperature is constant is this point here, somewhere here. Then go read what does it represent here. That's the temperature. So I can see it is 79 degrees Celsius. So the temperature, the boiling point here is at 79 degrees Celsius. 79 degrees Celsius. Determine the heat given out by steam between 0.5 minutes to 5 minutes. Determine the heat given out by steam between 0.5 seconds to 5 minutes. Learners, how will we answer that? Because they want the heat. Remember that we have from the question here, the power, the heater is rated as 50 watts. That is the power. Then we've been given the time interval. So to get that, we are simply going to take, to get the heat, it is going to be 50 times from 5 minus 0.5. Those are minutes, but I have to convert it to time by multiplying it by 60. That is when you work it out, I'm going to get 1350. Sorry, should be 1350. Should be 1350. I know there's someone who is questioning me. Learners, hope I am assuming you remember this formula that heat is equals to PT. Heat is equals to power times time. Power is 50, then the time interval between 0.5 and 5, you take 5 minus 0.5, then convert it to SI unit by multiplying it by 60. So I'm getting 1350. Because this is heat, the SI unit is joules. Power is equals to, heat is equals to power times time, but working with it in SI unit. From the graph, determine the temperature change between the times 0.5 minutes to 5 minutes. It's very simple. Go to 0.5, learners, 0.5, then read the corresponding Y value. Read the corresponding Y value. Do the same when do the same for the 5 minutes. Is like just like somewhere here at 50. Sorry, not at 50, at 5.0. Remember, this is 5.0. I don't have a ruler, so my line will not be that straight, but from me again, it's not like that. You read the corresponding value. It's along that dark line. So this one I think is at 70. This one here, let's see, at 0.5. That is let me just expound this better. If you look at that reading, it's at what can that scale be? Let me just redraw, so that not even redrawing, let me just be very keen with it. This is 5, 10, 15, 20, so each is 1. So this is 5, 10, 15, it's at 16. It's at 16. I can see this one should be at 16. If you observe it very keenly, it's cutting at 16. It's cutting the y-axis at this point, and this reading is 16. So having done it like that, having seen it like that, it is now quite simpler, because so the temperature, what was the question? Find the temperature change. So it is 70 degrees Celsius, you minus 16. That one is giving me 54. Find the temperature, 54 degrees Celsius. Question number 2, hence determine the specific heat capacity. Hence determine the specific heat capacity. Remember, heat we want to start from this side because it might take some space. Heat is given by m c delta theta. So heat, how do you get your heat, learners? Heat, remember, when you come, let's see what is required of us. Determine the specific heat capacity. We are told to determine our specific heat capacity. Specific, so we have the mass. The mass of this is just a moment. The mass is 100 grams. The specific capacity is what we are looking for. The temperature change, we have it. And let's see, because you know that what was providing the heat, we had I can talk of it as the power of 50 watts. At what time interval between so that is let's do this question well. So I'm going to take, let me just use a calculator. So the power, because it's being provided by the heater, it is power, which is what's the power ratings here? 50 watts times in fact, even this is what is 28 given out between this one. Let me just see. In fact, even no need to tire myself again because I had it computed. This is the heat that was being given out at that point. So it is 1350. This is 1350. Should be equals to m. I've gotten m as 100. But make sure you convert it to grams by dividing it by 1000 times the c which we are looking for times the time interval which we got at as what, as 50, sorry, the temperature difference, which is 54. So when I make c the subject, I'm going to get c is obtained as 1350 divided by 0.1 times 54. 1350 divided by 0.1 times 54. So let me just see what I'm getting from my calculator, because I told you, learners, we are working out this together. So that is 1350 divided by 0.1 times 54. I'm getting 250. Just a moment. There's something that's not adding up well on my side. There is something that's not adding up well, because power is equals to PT, temperature difference. Hey, learners, there's something I've not done well, and that is on how I've gotten my heat. That is the PT, because power is given by PT and heat is given by PT. That was 50 times temperature difference between and time, PT and time, that is just a moment, times, that is 4.5. get 225. Oh my god, what did I do wrong here? Then times 60, that is 225, then times 60, what do I get? Oh, it should have been 13,500. Just a moment, I don't know, what am I not doing well? How do you get your PT, learners? Our PT here, let me just get back here. My PT learners here, because I'm not seeing it adding. PT is given by power, which is 50, times the time. What is the time? From 0.5 to 4.5, that is sorry, to 5, that is 4.5. Remember that those are minutes, then you multiply again by 60. Okay, so I'm having 50 times 4.5, I'm getting 225. Then the 225 that I'm getting, I have to multiply it by 60. It will give me 13,500. 13,500. 13,500. 13,500. So it meant, what did I multiply at the top there? 50 times 0.5 times 60. 50, no, so 50 times 4.5. Yes, so this could have been 13,500. I'm the one who missed from the top. Yes, now I think that one is okay. So now we divide it by 0.1 times times 54. I'm getting 2,500. 2,500. That's now good analysis. It is specific heat capacity. So what is the SI unit? Specific heat capacity and heat capacity. So this, for specific heat capacity, it is joules per kilogram per Kelvin. 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 We are done. Let's look at the next one. 1.8 grams of vapor was collected from the liquid between the times 6.8 and 7.3 minutes. Determine the specific latent heat of vaporization. From that, you know that heat is given by mLV, but heat is given by PT is equals to mLV. Our PT, we've gotten our PT as 13,500 should be equals to, determine that, what is the mass? The mass is this 1.8 times 10 power negative 3 to convert it to kilogram. Then determine the liquid collected. That will be times LV. Let me just see between what was the heat being served. 7.3 minus 6.8, that is 0.5, so that's just correct. So what is my LV here? The latent heat of vaporization. My LV is given by 13,500 divided by 1.8 times 10 power negative 3. So that is use that with the aid of a calculator. 13,500 divided by 1.8 times 10 power negative 3. 7,500. Just a moment, let me see. Just a moment. Let me see that calculation. Let me see my calculation. My calculation is my calculation okay? Is my calculation okay, learners? Let me just a moment. Let me check. Let me recheck my calculation. Also, as I'm doing it, please can you also do it on your side? Yeah, it's okay. It's okay. Because let me just see. That is 13,500. You know, I might be omitting, divided by 1.8 times 10 raised to power -3. Yeah, that is 7,500. Not 7,500, but 7,500,000. 7,500,000. What is the unit? Joules per kilogram. Don't forget units in physics. Joules per kilogram. Joules per kilogram. So that's exactly what we were to do. That's exactly what we were to do. Well, that's exactly what we were to do. Let's look at the next question. Let's look at the next question. Determine angular velocity. This is simply just the rate of change of angular displacement with time. As simple as that. Angular velocity is defined as the rate of change of angular displacement with time. The rate of change of angular displacement with time is what we call angular velocity. Part B. The diagram below shows an object of mass 2 kg while on a vertical circle of radius 0.8 meters at a speed of 50 meters per second. So this speed is what we'll talk about, the v. Then this is our mass m. Then this is our radius. Sorry, it has misbehaved. I'm sorry for that. This is our mass m. Once we know it like that, determine the centripetal force. Centripetal force is given by mv squared over r. So centripetal force is normally given by mv squared over r. So what is our mass? Our mass is 2 times our v, which is 50, but now squared, divided by r, which is 0.8. I'm saying all of them are incorrect units already. So when you work it out, you're going to get 6250. Remember, these are force, so the unit should be Newton. 6250 newtons, dear learners. mv squared over r gives you what you call the centripetal force. The tension in the string when the object is at A. How do you get that tension? At A, to get the tension at A, we normally take the centripetal force, which is mv squared over r, minus the weight, which is given by mg. So this is going to be 6250 minus the weight. How do you get the weight? The mass is 2 times 10. I want to be procedural. 2 times the gravity, which is 10, so that's 20. You less 20 from that, you get 6230. Tension, learners, is also a force, so the unit is newtons. Then the tension when the object is at B, at the bottom here you add centripetal force plus the weight. Tension at B is given by centripetal force, which is mv squared over r, minus the weight, which is given by mg. Sorry, this should be plus because it's at the bottom. So that is 6250 plus 2 times 10, so that is 6270. 6270 newtons. So that's how you do that calculation. The speed of rotation is gradually increased until the strip snaps. To snap, what is the meaning of that? The word snaps. It breaks. Okay, that is the meaning of that word there. At what point is the string likely to snap? Learners, the string is likely to snap at a point where tension is greatest. Look at point A and point B. At point A, the tension is smaller because we are taking centripetal force minus the weight of the object. At point B, the tension is maximum because tension is obtained by taking centripetal force plus the weight. So it's most likely to at point B, at the bottom. So at the bottom, that is a point B. I've stated, then explain that point. At this point, I can talk of it at B, comma, tension, which is given by mv squared over r plus mg, is greatest. The tension at the bottom is greatest. That's how you can explain that. State the principle of parallel forces, learners. It states that the sum of upward forces is equal to the sum of downward forces. This principle of parallel forces states that sum of upward forces, the sum of upward forces is equal the sum of upward forces is equal to the sum of downward forces, is equal to the sum of downward forces. That's how you could have explained that. Part B, a uniform plank of wood weighing 50 newtons. A uniform plank of wood weighing 20 newtons and of length 5 meters is suspended by two ropes A and B 1.5 meters apart. A is 2 meters high, so 2 meters from end B. Sorry, A is 2 meters from the end and B is 1.5 meters from the other end, as shown in this figure. A concrete block of weight 100 newtons is suspended from the center of the plank, like that. Calculate the tension, that is the tension at A on string A. we reread the question again. A uniform plank of wood weighing 50 newtons, that's the weight of the wood, and of length 5 meters. I want to do that analysis from that point. And of weight 50, of length 50 meters. So if it is at 50 meters, in between at the point where that is at the center, 5 divided by 2 is 2.5. At somewhere here at 2.5, I have the weight, and that weight should be 50 newtons, because weight acts at the center, should be 50 newtons. 1.5 apart, the distance between the two ropes is 1.5 apart. A is 2 meters from the end and B is 1.5 from the other end. Determine the tension at A. The tension at A. So what we learn, a concrete block of weight 100 newtons is suspended. Let me first just remove this and work with what is there. So we have a concrete block of weight 100 newtons suspended from the center. I'm getting now that point. From the center of the plank. From the center of the plank. Now, from the principle of parallel forces, we've seen that the sum of upward forces should be equal to the sum of downward forces. But now, because they are saying that this concrete block, the concrete block is suspended at the from the center. From the center. So, sum of upward forces should be equal to the sum of downward forces. Sum of upward forces should be equal to the sum of downward forces. You know, learners, in this question, we need to be very smart. We need to be very smart when answering this question. We need to incorporate all what we've learned. All what we've learned, so that we can exactly get what we want here. Because this question is testing a lot of things. I'm requesting again, before I start working out, can you reread the statements and make sure you've literally understood what the question is asking. You've literally understood what the question is asking from you. What the question is asking from you. A uniform plank of wood weighing 50 newtons. The weight of the uniform plank of wood alone is 50 newtons. From what we are being told, the weight is 50 newtons. The weight is 50 newtons. That's what we know. And the weight, we all agree, it acts at the center. The weight, we all agree, it acts at the center. 1.5 meters apart A. So A and B are 1.5 meters apart. A is 2 meters from the end and B is 1.5 from the other end. So they are asking, let's do calculation. Calculate the tension at A. So how do we work it out? How do we work it out? The first thing we can say, let's make A to be the pivot. And once I make A to be my pivot, I'll have it like this. Let me get, if A is my pivot, let me take taking A as pivot. Taking A as pivot, taking A as pivot, I know that for assisting in equilibrium, clockwise moment should be equals to anti-clockwise moment. So F1 D1 should be equals to F2 D2 should be equals to F2 D2. So in the clockwise moments, I'm having 100 newtons. That is 100 times its distance from the pivot. You remember this one is tied at the 2.5 mark. So if here is 2, this is 2.5, so that is 0.5. The interval is 0.5. But also I'm having the mass. Okay. I'm having the mass, the weight of the block, 50 newtons. 50 newtons. So plus 50. Remember, I'm having the weight somewhere here. Not even somewhere. I'm having also the weight acting here. And that weight is 50 newtons. Don't forget. So it's 50 newtons times the perpendicular distance from the point of support. Times the perpendicular distance from the point of support. From the point of support, what do we learn? From the point of support, from the point of support, that should give you let's just cross check. Wooden concrete is suspended from the center of the plank. These are wooden plank, so that one also should be equals to times because this is 2.5, this is 2, that is still 0.5, because they are all acting at that point. Should be equal to F2, which is now F2 is the tension due to B times the distance. If this is 2, this is 1.5, that is 3.5, so the remaining should be 1.5, like that. So this is giving me that is giving me let me just see. If you look at this suspension keenly from the center of the plank, so this is like saying just this was 1. Sorry, why am I doing like that? This is 1. So this becomes 100 newtons. 100 is equals to 1.5 TB. So my tension at the bottom, is given when I divide it. My tension at B, not at the bottom. My tension at B will be 66.67 newtons. 66.67 newtons. Now, after I've gotten that, I know that tension at A, upward forces should be equal to downward forces. So tension at string A plus the tension at string B should be equal to downward forces. I'm having the weight of this concrete block, which is 100. I'm also having the weight of the block itself, which is 50. So that means tension at A is given by 150 to minus 66.67. That gives you when you minus, that gives you 83.33 newtons. 83.33 newtons. Then Roman 1, State two ways in which stability of a body can be increased. Ways of increasing stability of a body. One, lowering the position of COG. Lowering the position of COG. Remember that COG is the center of gravity. Lowering the position of COG. Lowering the position of COG. Two, another factor we are having is increasing the base area. Increasing. Learners, remember that this one you are just getting from factors affecting stability. Increase the base area. That's why when you've watched those rugby games, when someone is to make a tackle, he's being told go as low as possible to lower down the position of COG. If you see those guys who do martial arts, they always keep their legs far apart so that to gain more stability by increasing the base area. State one application in which the vehicle assembling companies enhance stabilities in vehicles. How do they enhance? So the heavy engines are placed as low as possible. The heavy engines, engine is very heavy. So one, you can say heavy engines are positioned as low as possible. Another way in which they enhance stability, you can say that luggage compartments placed at lower part of the vehicle. The luggage compartment. The luggage compartment positioned low down. Another way, not factor, you'll find them, the tires are fixed far apart for a wide base. Tires are fixed. Tires are fixed far apart for a wider base. For a wider base. And many more. There are so many. You can even just talk about the heavy chassis placed at the base and so on. Let's look at question number 15, which will be our last question for the day. The figure below shows a ball of mass 50 kg being thrown from a top of a hole 20 meters high with a horizontal velocity of 20 meters per second. It struck the piston A of hydraulic lift and no water splashed out. The other piston B had a weight of 25,200 newtons placed on it. Assuming the tap was opened at the time the ball struck the piston A. So you can see from the diagram, we have the ball being thrown, goes down, lands to piston A. If it lands to piston A, we expect some water to get displaced. Determine from an 1 the time taken by the ball to strike the surface of piston A. The time taken by the ball to strike the surface of piston A. You know that from the second law of linear motion, S is given by ut plus a half gt squared. But because it's a free fall, it's being thrown from the top, but you know that it's free fall, then but u equals to 0. So if u is equals to 0, then it means s is given by a half times 10 times t squared. But what is the s? What is the distance? The distance is 20. So 20, a half times 10 is 5. 5t squared. So 4 is equals to t squared, meaning time is equals to 2 seconds. 2 seconds, as simple as that. Then the distance from the foot of the wall to where it hit piston A, from the foot of the wall to where it hit piston A, that is the range. They are talking about the range. And we know that R is equals to ut. What was the initial velocity? 20. The time was 2, so the range was, the range is 40 meters. 40 meters, as simple as that. 40 meters. The vertical velocity with which the ball struck piston A. The vertical velocity at which the ball struck piston A. So you know that V from the first equation, V is equals to U plus GT. V is equals to U plus GT. But still we know that U is 0. So V is equals to 10 times T, which is 2. This makes it to be 20 meters per second. 20 meters per second. The force with which the ball struck piston A. The force from Newton's second law, you know that force is being given by, just a moment, force is given by ma. So force is equals to mass times acceleration. Mass times acceleration. What is our mass? Remember, this ball has a mass of what? Of 50. So remember, that can be written as mass. Acceleration is v minus u over t. So this can be 50 because it's 50 kg. So it's 50 into, what is the final velocity? The final velocity is striking that knee. The final velocity is 20 minus 0, v minus u, that is 20 minus 0 divided by t, which is 2. So that's like saying 50 times 10, which gives you 500. It's a force, so the unit for force is newtons. 500 newtons. The area of piston B, if the load on piston B did not move and that the two pistons were initially at the same levels. The area on piston B. So having a look at the diagram, I'm going to talk about pressure applied at one point being equally transmitted to all other parts. So F1 over A1 should be equals to F2 over area 2. That means our force 1 learners is 500 over area 1 area 1 from the diagram is 50 in 5. This is 500 watt, 500 newtons over 50 squared centimeters should be equal to area force 2, which is force 2. Just a moment, let me just cross check. Force 2, that is 25 200, 25 200 newtons over area 2, which we are looking for, Now this is like saying area 2 can be obtained by saying 50 squared centimeters times 25 200 newtons over 500 newtons, such that the newtons and the newtons will cancel out. The newtons and the newtons will cancel. The newtons and the newtons will cancel out. So this will become, when you work it out, you will get 50 times that divided by 500, 2520, and the unit remaining is squared centimeters. 2520 squared centimeters. Learners, we've come to the end of that paper. It was a good paper. Thank you for being part of the team. Thank you for watching. Make sure you've subscribed and hit the bell icon so that not to miss any update. Our consultation number remains 07 41 30 43 11, but kindly make sure you subscribe to our channel. Subscribe to our channel and hit the bell icon so that to keep notified anytime we share a video. Thank you.